Okay, I'll try to make this quick. So some of you fellow gearheads might appreciate this. So this is a Barnes & Noble model 4-cylinder engine that you buy as a kit and you assemble it. It took Tristan and I about an hour to do. You do have to time it, and it does have a distributor back here that runs these 4 LEDs that replicate spark plugs. So I bought it assuming it was going to turn over faster than this, but it is only 3 volts. This is a 3-volt battery box to a 3-volt DC motor. I'll show you right now. So it's not very impressive. It is cool, it does make a good shelf piece, but I'll show you what I came up with to make this a little bit more exciting. Okay, after some time in Fusion 360 and 5 hours on the printer, this is what I came up with. So that is a 6 to 12 volt Power Wheels motor. I believe it is 9T to 12T, which means 9,000 to 12,000 RPM, or 9 turn to 12 turn. I do eventually plan on wiring in a series of buck converters or a speed controller so I can precisely control the RPM of this model motor. But for now, I intend on running either 6 or 12 volt bursts to the Power Wheels motor to see how this model engine will handle the extra RPM. This is about 3 to 5 times bigger than the motor it comes with, so I do plan on something breaking, and when it does, what I'm going to do is 3D print an upgraded part. And basically I'm going to push for it as long as I can until this is either garbage or completely 3D printed. Okay, so I removed the bell housing off the back of the model engine, and that is what is left. There is a small black ring drive here that is driven by this gear here with the original motor. And like I said, I was going to do a side-by-side comparison. Here's the one we're putting in, and here's the one it came with. And you can see the size difference is quite drastic. And let's see if we can even get this on in this clip. Probably quite tricky. Let's see. Oh, nice. Let's see. I'm going to just screw that in. So I remembered I had some of these roller skate bearings from my old pair, and I figured I can use it to fix this issue where it's pulling up and basically heating up the plastic and slowing itself down and also wearing it out. So what I'm going to do, I'm going to take one of these bearings and it's probably going to Dremel this part here and then 3D print some sort of adapter and then run a bearing in there to keep that pressure off. And this should rev a lot better as long as those hold up, or I'll just 3D print some new caps. Okay, so we're back with the model engine and definitely made some huge improvements on this. You can see I finished up on 3D printing a bearing housing along with a new crankshaft pulley. And the reason why I did that is because the serpentine belt along with the timing belt here was pulling up on that point with a crankshaft run through the block, causing the plastics to basically heat up and lock themselves together, which was just no good. Now we also have a speed controller. I just got this off of Amazon for like $12 or $13. Supposedly handles up to 24 volts at 8 amps. We're only going to be doing 6 volts, maybe around 3 amps with this motor. We'll start it off as an idle. We'll idle it for a little bit, and then we will slowly ramp it up to see what it can handle. It may or may not break. I kind of want it to last a little bit, but if it does break, like I said in the previous videos, I will 3D print some upgraded parts and see how long we can push this for. I'm going to do my best to film this with one hand, and obviously the setup here is temporary. I will eventually 3D print some sort of bracket that houses all these controls and it'll look a lot better. So for now, I guess we'll turn it on, and I will note that the screen is upside down, so ignore it. We'll start it off at a low idle, and then we will slowly ramp it up. The timing belt doesn't look so happy, does it?